Hi everyone, welcome to week 6 for geometry. This week it's a recorded session for you since I'm out of the office this Thursday, Friday. So I have a little bit of a puzzle up here on the screen for you, and we'll actually start next week's session with this, so I just wanted to give you a chance to think about it. It says, which area is bigger, the total orange or the total red? I don't really see orange and red. We should say the total half circles or the total yellow maybe. I kind of see red and yellow. Let's call it yellow. So think about the yellow squares versus the red semicircles, and we'll come back to that answer next week. So for this week, we are working on Unit 2, Sections 2.03 through 2.07. I did share with you the PowerPoint slides, so feel free to copy those off and have them in front of you. It makes the session run just a little bit more smoothly if you don't have to take a lot of notes. So our week 6 essential question is actually coming later in this session, so I just want you to stay tuned and keep your ears and eyes peeled for that. Let's review some shapes real fast. I did this in the week 5 extra credit session, but it's always good to make sure everyone has the same starting knowledge. So anytime we see one, like up here in the left corner, and it's coming to a point. So I have two different shapes that come to a point. What makes them different is their base. So the one up here on the top left has a square base or a rectangular base, if I were to draw those lines in. The one down here in the lower right actually has a circular base. So anything that has a rectangular or a square base, that's going to be called a pyramid. Anything with a circular base is going to be called a cone. Over here on the lower left, this would be called a prism. So a prism is any object that's going to have two of the same bases. So here I have the same base on the top and on the bottom. That's called a prism. This one that has a circular base on the top and the bottom. So that's like a prism, except a prism sort of has rectangular or square sides. And this one has a circular bottom. So this one will be called a cylinder. And the one in the middle is a sphere. So let's label a couple quick things. I want to make sure you guys know some of the differences about each of these shapes. And again, these few theme slides were on the week 5 extra credit, so it might be a quick review for you. You have 3 different formula sets here. The first formula set is if you have a 2-based object. The middle is if you only have 1 base. And the bottom is if you have 0 bases. So let's kind of come back to my picture so we can identify which one would have 2 bases and which ones would have 1 base. So my pyramid down here only has 1 base. My cone also has 1 base. And those would be our shapes that come to the point. So if we're going to add this to our notes, we could say this is 1 base, this is 1 base. Next I have ones with 2 bases, so that would be my prism and my cylinder. Then I'm left with the shape in the middle, which is a sphere, and that actually has 0 bases. It does not have a top or a bottom. Okay, so keep these formulas handy. I would even put a post-it note on this page, flag it, so that way you have it for every quiz and every test. You can just come back and take a peek at your formulas. So, quick quiz, which of these objects have 2 bases? So on a quiz, it might phrase it to you in this manner, where it gives you multiple choice options. So take a quick minute and read over your options. So we said spheres don't have a base, I can cross that off. Pyramids come to a point, cones come to a point, so the only one that would have 2 bases for both of your options would be D, cylinders and prisms. Next, which objects only have 1 base? Go ahead and read through your answer options. And the answer would be B, cones and pyramids. They both come to a point at the top. And then lastly, I'm going to phrase it a little bit differently. Which objects would have a slant height? slant height sounds just like it sounds. It's going to be a height on your figure, meaning it is going to form a 90 degree, but it's going to be a slanted height. So our two objects down here that are going to have a slant height is C, my cones and my pyramids. Because if I were to draw one here, and this is what you're reading about in your lessons right now, your regular height always makes the 90 degree with your base. Always. That's your regular height. Your slant height is going to be the one that goes along the edge of your shape. It's still going to make a 90 degree with your edge, but it's slanted. So your slant height is going to be designated with the letter L. I do my L's, cursive L's, that way they don't look like the number 1. So in our formula, let's kind of take a peek back a couple slides. If we're looking at our formulas here, so here I have my big B and my P, which we know area of the base, perimeter of the base, but now I'm getting this new letter in here, this L. So now L is going to stand for your slant height. H is always your regular height. L is going to stand for your slanted height. So let's try a few. Okay, example 1, we're going to do a triangular prism, and I want you to find surface area and volume. So the first thing I'm identifying is I have 2 bases. For 2 bases, here is my formulas that I'm going to be using. So let's start off with surface area. So I'm going to do 2 times my big B. Big B means area of my base. So I'm going to shade that in blue. Now, since it's a triangle, let's fill in my triangle formula. My triangle formula is 1/2 base times height. So in my triangle down there, that's going to be 1/2 4 times 6. Then I'm going to do my perimeter of my base. So the perimeter of my base means to add all sides. So right now they're showing me 2. They're showing me one side is 4, one side is 6. So I know 2 of my numbers so far. I'm going to have a 4 plus a 6 plus an I don't know, because I need to find my third side of that triangle. I'm going to put a little question mark there. And then times the height of my whole figure. So my H, my height of my whole figure, is times a 10. So the only thing that I'm missing right now is the remainder of my perimeter. So let's come to my shape. And either your shape is going to give you the little square right there in the corner telling you it's the right triangle, or your problem might say that it is a right triangular prism. So either of those 2 keywords are going to help us know how I can find my unknown, my question mark. I have to use Pythagorean theorem. Okay, I'm going to give you a minute to copy that down and catch up to where I'm at. So I did 4 squared plus 6 squared equals C squared. I'm going to add both of those together, and I get 52. Now, I don't want to know what C squared is. I want to know what regular C is. So to go from C squared to a C, we take the square root of both sides. Now, I don't know the square root of 52 off the top of my head because it doesn't come out perfectly, so I'm going to use a calculator, and I got 7.2. So my remaining missing piece of my perimeter was a 7.2. So I'm going to add that in here. So let's finish solving. I'm going to go inside my parentheses first. And remember, all of these are just multiplied together, so you can really do them in any order you want. So half of 4, or 1/2 times 4 is 2. 2 times 6 is 12. So I still have this 2 out in front, but now my whole parenthesis became a 12. Let's add my whole other parenthesis. So 4 plus 6 plus 7.2 is going to give me 17.2 times 10. So let's do these multiplication problems. Here I have 24, and then here I will have 172. By the time I add them all together, 172 plus 24 gives me 196. And if we're talking surface area right now, my units are going to be centimeters squared. So please stop, take a peek at all of the steps that we did, because this is what you're going to have to be able to do on a test and a quiz. Now let's look at volume. Volume is big B times H. So big B is just the area of the base. We already did that, so let's write it in again. 1/2, 4 times 6, times the height of my whole shape, which is 10. So 1/2 of 4 is 2. 2 times 6 is 12. So I'm left with 12 times 10, which would give me 120 centimeters cubed for my volume. Surface area is usually the trickier one of the two to find because it has a couple more steps to it. But really, you just have to keep in mind, as long as you know what big B means and what big P is, you're able to find those items. Just sometimes the P portion, you have to use Pythagorean theorem to find your missing side. So that's example 1. We have a couple more to go. Example 2. Now we're going to do a triangular pyramid. We're going to find surface area and volume. So notice I picked out the formula for the one base object. So I'm going to give you guys a quick minute. I want you to fill in what is big B. I want you to try and fill in what your perimeter is and what your slant height is. So take a quick second and try that on your own, and then press resume when you're ready. So for my big B, that's the area of the base. In this case, they told me that one of my bases is 10, and since this is a square bottom, I know that that's going to mean 10 times 10. So my area of my base, I can just say 10 times 10, which we know is going to be 100. Now P means perimeter of the base. How do you find the perimeter of your base? You add all edges of the base. So if this side's 10, 10, 10, 10, and 10 would make 40. Your perimeter is going to be 40. Now my slant height, make sure you put the right number in here. It's either going to be the 11 or the 13. Now they're both a different kind of a height because they both make 90, but only one of those two is your slant height. Slant height is the one that goes along the outside edge of my figure. So in this case, my slant height would be 13. From here, we're just plugging and chugging to the final answer. So 1/2 of 40 is 20. And then I can do 20 times 13. Oops. 20 times 13, which is 260. So 100 plus 260 equals 360. Since we're still talking area, I'm going to say meters squared. Now we're going to try volume. So I'm going to switch colors. So it's 1/3 big B. So big B again is the area of the base. The area of my base is just 10 times 10, so that's 100. And this time it wants H. It wants your real H, not your slant height, your regular H. That would be the 11. So how am I going to work this out in a calculator? Well, because this time we can't really do 1/3 of 100 in my head because it's a decimal. So what we can do is in a calculator we can say 100 times 11 and then divide that answer by 3. Because by now we should all recognize that this, we could say 1 times this number divided by 3. So we're allowed to do these two and then divide by 3 at the end. And my answer that I'm going to get is 366.67. And since this is volume, I'm going to say meters cubed. So area is always squared, because area is in 2 dimension and you're measuring a flat surface area. Volume is always cubed because we're measuring a 3D space. How much volume can fit inside of that shape? So remember, you can pause and rewind these examples as many times as you need to make sure that you're really understanding the content and how we got each part of our number. We have one more example to do together today. So your week 6 essential question says, what page in your textbook can you find all of these formulas? So I need a textbook number because I want to know, do you know where to find all of these formulas? So that's part 1 of the question. And then part 2, it says the next example will explore cylinders. How, meaning you need to describe your steps. How do you find P in a cylinder problem? And we're going to do that next. So make sure to pause the recording, copy down your essential questions. There's 2 parts this week. And when you're ready, press play. So first, let's identify that a cylinder is a 2-based object, right? There's a top, there's a bottom. They're both circles this time. So my surface area formula is 2 times big B plus P times H. So 2 times big B. Big B means area of the base. But wait a minute. My base is a circle. How do I find the area of the circle? Area of a circle is pi r squared. So right underneath my big B, I'm putting in my formula for my area of a circle. Now right underneath that, I'm going to fill it in with my number. So in this particular example, my r is 6. So I'm going to get 2 times pi 6 squared. 6 squared is 36. So we're always going to put our number in front. My pi is going to go second. So that's where we're at so far. So stop and make sure that that makes sense. Big B is always the area of the base. But in this case, my base is a circle. So I have to substitute the right formula. The formula is pi r squared. My r was 6. So 6 squared gives us 36. Now it wants the perimeter. Perimeter of the base. Again, my base is a circle. How do you find the perimeter of the circle? So the perimeter of a circle is actually its circumference. Because circumference is the distance around the edge of the circle. Kind of pieces of the puzzle are fitting in here. And we have a formula for circumference. It's 2 pi r. So instead of using P, P means perimeter of the base. I'm still doing that. But in this case, since it's a circle, my perimeter is 2 pi r. Let's fill in what I know. So my 2 will stay 2, pi stays pi, my r becomes a 6. So again, all 3 of these are touching, which means all 3 of these are multiplied. So I can do my 2 times 6 and put that out in front and say 12 pi. Now I still have to add in my h. H stands for height of your whole figure, so that would be the 11. We are almost done. You guys are doing great. So here I can do my 2 times my 36, which would give me 72. And on the next part, I can do my 12 times 11. Think about why I'm allowed to do that. This says 12 times pi times 11. See, they're all multiplied together. So I'm just doing my normal numbers first. So 12 times 11 gives me 132 times pi. We can sort of think of pi like a variable. If I had 72x plus 132x, I'd be allowed to just add the 2 numbers together. You can do the same thing here. So my 72 pi plus 132 pi gives me 204 pi centimeters squared. Because that is asking for area. So, same formula as before, exactly the same. It's just now when we're talking about my big B, we're talking about area of a circle because my base is a circle. Now when we're talking big P, I'm talking perimeter of my base, but again, my base is a circle. How do you find the perimeter of a circle? Perimeter of the circle is the same as circumference. Circumference is 2 pi r. So one last thing, if you don't see this answer on a quiz, the answer that you might see is 204 times pi. They might actually work it out to be a decimal. So when we use decimal approximations, we are really using 3.14. Let me just put that in. So 204 times 3.14. So the other alternative answer that you might see is 204 times 3.14, which would be 640.56 centimeters squared. So here are the two answers you'd be looking for. The first answer will have pi left in it. The second answer does not have pi left in it. They would only give you one of the two options. They would never have both on there because they are the exact same answer. I'm just making sure that you guys know 204 pi is the same as 640.56. Please know those are the exact same. All they did was they took pi and they substituted 3.14 and multiplied it out. So that's surface area. Excuse me. Let's try volume. So volume equals big B times H. We like volume. Volume is always way shorter. So big B, again, is going to be pi r squared times H. So let's plug in what we know. So pi, my r squared, 6 squared, times the height of my whole shape, H. So I'm going to get 36 pi times 11. And 36 times 11 is 396 pi centimeters cubed. That's one answer. The other way that they may write your answer is they might multiply 396 times 3.14, and that would give us 1243.44 centimeters cubed. So again, just know, two different answers. Well, two ways to write the same answer. That's a better way to phrase it. Same answer, just two different formats. One keeps pi in there, the other one multiplies pi out. So that wraps up our week 6 session. Please remember to put your answer to the essential question in the week 6 Dropbox, and I hope that you guys have a fabulous week.